Okay, so hello. Today I want to show you my SPS Reef tank system. It's a small cube that I custom made. It's 45 centimeters wide and 50 centimeters deep, and the water is at around 35 centimeters. You can see that it's mainly SPS in there. So I'm really into corals, not too much into fish, but I nevertheless have them in there because I think they're important for the coral growth. And yeah, I have different kinds of SPS corals, Montipora here in the back, Stylopora, Ceratopora. I also have some Acropora, which are still quite small here. And then here in the back I have some LPS corals here and here. As a light I have AI Hydra 26 HD. It's a rather strong light. I run the Saxby program on there. I run also here the Narrow 5 wavemaker. You can see that I always have a rather turbulent waves on here. I like it if things just move. For summer I have small computer ventilators in here that are actually controlled by my Raspberry Pi system that I will show you later. So if the temperature rises too much, it will get cooled down by these, and those two ventilators are actually for sure enough for this tank. The whole system has around 100 liters, so it's not so much. Then I have an auto feeder on here. In general, the whole system needs a lot of nutrients. I'm feeding a lot. Still, I have to add phosphates and nitrates, otherwise my corals would just start to die because they really consume a lot. So going down from the main display tank down here to the sump, which actually is at the same time my frag tank. So the water basically comes down here to this 3D printed device I added or I made here, where I can add filter wall, and I also can add this here, which is actually activated carbon, so I can just put this in here if I need it. I do this like once a month. And maybe you noticed I don't have any skimmer. I don't need a skimmer because I more have the problem that I have too low nutrients than too high nutrients. So lighting, I here have AI prime light. It's sufficient to grow SPS frags in here, so that's not a problem at all with this one. As a pump, I have a rather huge pump from Aquamedic, which pumps around 3000 liters per hour, but I have it only in the lowest level, so it's more around 1000 liters. I wanted to have a big one because it's more quiet if I run it on the lowest level. And in addition to that, basically one part comes directly back to this frag tank to have some flow in there. Other than that, here in the back I have the RDI water store for the auto top off, which is a Tunse auto top off. I adapted actually the holder for this auto top off because the other one always got stuck because of snails, and then the emergency stop would kick in and it wouldn't work anymore. So I just 3D printed this part here, and it works really nicely now. I didn't have problems for months, and before I had it every couple of days because I have quite a lot of snails in here. So I have also here two ventilators so that it's not too humid in the sump area, because I do have electronic parts in here, so I don't want them to break. For dosing I use the ATR Essentials Pro, which I have down here. Yeah, I have an auto doser, no problem at all with the system. Nice coral growth. I add a lot of phosphate, so I add 0.03 milligram per liter per day, and also I add some nitrates here, otherwise corals would die off, although I feed quite a lot. So the electronics I actually have in a separate cupboard down here, and this is all DIY solution, so controlled by a Raspberry Pi with a display here. This is easy with the plugs, it's just some plastic boxes, electronic plastic boxes with plugs, and then here I have some relays that are controlled by the Raspberry Pi. It's connected here, and then I wrote a small graphical user interface where I can control them on and off, and I have some programs I can run, and it shows me temperature, the room, in the sump area and of the aquarium, and with this I then can also control temperature. If it's too high, then the fans will switch on, and so on, and this is all in this housing here, and that I 3D printed. That's a custom made thing, and here's the Raspberry Pi, and you see lots of cables. It's quite messy, but it works. It actually works very stable, and I also wrote some scripts that if there's a problem, I will get messages or emails, and yeah, this gives me peace of mind when I'm on holidays. It's also nice that if there's a problem, I can actually, with my mobile, I can access the Raspberry Pi. So if I'm somewhere on holidays, I can switch on and off things as I need them. So that's really nice. In general, I made the system to be as autonomous as possible. I can go on holidays for 2 weeks, no problem. It all works with the ATO. Actually, I would have enough for 3 to 4 weeks in terms of water. And yeah, it's also low maintenance. I don't change water, and I just measure and adapt the amounts I dose, like once a week for alkalinity, and once a month I check for phosphates, nitrates, and calcium, and adapt as I need it. But if I'm on holidays, I sometimes also don't measure alkalinity for 2 or 3 weeks. Never had problems with that. So if you like this video, then please let me know, and if you have things you're still interested in, then just leave a comment and I will try to make another video with more details. Thanks for watching.